The purpose of this video is to discuss a little bit of exam number 1, some of the questions that a lot of people struggled with. So I'm going to start here with some questions about this problem here. So this was the problem that talked a little bit about the number of students and how much time they spent studying for the exam, as well as the mean of the exam and how they did. So the first thing I noticed when I was looking at this exam was students struggled with questions like this one here I have written on the test. So one of the questions, depending on which version you had, it varied in number, but how many students scored, either how many students scored less than 75 or what percent of students scored less than 75 on the exam. So what we first have to do is find out the mean and the variance. And so if you look here at this table, you can see down here at the bottom is the mean and the variance. Now, of course I have 7, but really it should be 70 here, so let's just write that. So on average, students scored 70 with a variance of 25, which means then that the standard deviation is 5. So what we could do is go take a look at this normal distribution that I have drawn on here, or we could use z-value computation. So I'm going to do it both ways just so you can kind of see how to do it, and I'm going to erase this question and we'll get to that one in a minute. So the first thing that we want to do is let's just do the z calculation. So we're going to figure out, essentially, z tells us how many standard deviations away our number is from the mean. So we want to know how many standard deviations is 75 from 70. Now we know it's going to be 1, right, because we can do this in our head, but we're going to write it out in here anyways. So 75 minus 70 divided by the square root of 25, which of course is 5. So this is going to equal 1. Now we're going to go look up 1 on our z chart, and I'm going to go ahead and do that because I think there was some confusion about this as well. So what we want to do is use our z table here to find the number 1. So we see it right here. And actually, in this case, it's exactly 1. So we're going to stick with this first thing right here, 0.8413. And we'll just note it over here on the side, because then I'm going to move this chart away so I can write on here. So we know that, we understand where that 0.84 came from, and so we're going to go ahead and write that up here. So we have 1, which we know is a z-value, and that z-value equals 0.8413. So, oops, I left off the 4. Hold on, let me fix that. 8413. Okay, now I'm going to zoom in on this table here, the curve, and I'm going to draw for you exactly what we're talking about. So first thing I want to do is label this. So in the middle we've got 70 because that is the mean, and each standard deviation, or this area right here, is worth 5. So this then at plus 1 standard deviation would be 75, and then this one would be 65. So in this problem they're asking the number of students who scored then less than 75. So in this case we would essentially draw a line right here, and we want to include all of the students to the left of this thing here. So when we include all of the students to the left of this thing here, it incorporates 84% of the population. 84.13 to be precise, but 84% is good enough. So from there I either asked you the percentage or I asked you the number of students. So we now know we have 84%, and we can then either do 84%, which is going to be just plain old 84%. That was one answer. Or I asked you how many students, so in that case we would just multiply this by the n, or the total number, which was 200, which would then give us 84% of 200, which would be 168 people. Now, if I asked you the opposite of that, which would be how many students scored greater than 75, then we would do exactly the same thing, but in this case, we would have z equal to, I'm going to change the color of the pen just so you can see it's different. So it would be then z equals, again, same, you could set it up the same way as long as you know, 75 minus 70 divided by 5, which is still going to equal 1. When we look that number up on the z-chart, we're still going to get 0.8414. But this time we're going to know that I'm asking you for 75 and beyond. So what I'm interested in is no longer what's to the left of 75, because in the last question I was interested in what was to the left of 75, but in this question I'm interested in what is to the right of 75. So I want to know this percentage. Well, if this side here is 84%, well, all that's left is, 1 minus 84, or 16%, is what's on the other side of the normal distribution. Again, you can multiply that out to get the number of students. So first we would need to do 1 minus 0.8414, which would be about 16%. And then if we wanted, of course, to find out the number of students, we could do 200 minus 168, or we could just do 0.16 times 200, and either way we come up with 32. So 32 students scored less than 75. So I hope that helps, and I'm going to end this video and then I'll do another one for the other problems. The purpose of this video is to discuss this problem from the exam that dealt with the University of Maine salaries. And in this video, I'm going to just go over some of the questions that people seem to struggle with more, and discuss how you might approach doing these problems, in the future. So on here you'll see I've got both a normal distribution and the information needed in order to do these problems about the salaries. So let's start then with the first type of problem, which was sort of how many people would score in this or that percentage. So one that a number of people struggled with was the problem that said too many faculty members earn more than $100,000 per year. So what's the probability that faculty members in group 2 earn more than $100,000 per year? So let's just step through how we might do that. So first, let's kind of write out the question so we know what exactly we're trying to do. So you can see I wrote out what percent of the faculty members earn more than $100,000 in group 2, and then I wrote out the mean and the standard deviation for group 2. So if we want to know the number of the percent of faculty that earn more than $100,000, we have a couple options. One would be we could do the z calculation, and then the other would be we could just sort of look at the normal distribution and eyeball it, and probably get relatively close. So in the other video I did the z calculation, or I spent more time on that. So I want to do this one by just looking at the normal distribution. So let's go over here and kind of zoom in on this normal distribution, and let's identify some key positions on here. So first thing is the mean is $90,000 for this group. So I just went ahead and wrote that down. I've got 90K in the middle here, and then I've got 83.5K to the left, because that should be 90,000 minus 6,500, and then 96.5 to the right. So we know first right off the bat that 68% of the faculty members in group 2 earn between 83 and hold on, this is just too big here. I've got to erase that. Between 83.5 and 96.5. So, you know, that's just an important, I don't know, thing to kind of note down, because that kind of helps get your head straight on all of this stuff. So if we just sort of color it in and we make a note to ourselves, 68% of these guys earn between 83 and 96. So let's just write on here 68%. All right, so we know that. Now our question here is how many earn greater than 100,000? So greater than 100,000, right off the bat, we know that our answer is definitely going to be less than 50, 60, 70%, really, actually, because we know our answer is going to fall over here somewhere, right? Because we know 100,000 is greater than 96.5. So if we were to add another 6,500 onto 96.5, it would put us just a little bit greater than 1 standard deviation. So there, I've noted that on there. So we're right in our assertion that our 100,000 value falls somewhere between the first and the second standard deviation. I mean, you know, we could mark it on there. We don't know exactly, but, you know, probably right in here somewhere. So if we were to eyeball it and say, oh, let's just take half of that standard deviation and the rest of what we see here, we could just add together 0.13 plus 2.15 plus half of 13, so let's just say 6%. And we could see that that's about 8.2. So eyeballing it, we would guess it's about 8% or less. So now that we have that idea in our head, we can go now and do our z calculation, because now we don't have to mess with the minuses and do we subtract this from 1 or not, because that can be really confusing. So let's just go over here and go ahead and calculate the z value. So we're going to say z is equal to 100,000, so 100k minus 90k divided by 6.5k. And we're going to calculate that out. And we get 1.538. So now we need to look that up on the z-chart. So when we look it up on our z-chart, let's go ahead down here and so we can find our 1.538. So we come down here to 1.5 and we go across the top to 3.8. So 3.8 is pretty close to 4. So, you know, right in here somewhere, about 93.8, 93.7%. So let's just write that over here like we did before. Z is going to equal about 90, actually I'm going to write it like this, 0.93. 0.9380 roughly. So that's what our z value is. So that means that 93% of the people earn less than 100,000, and about, what is that, 6 point something percent, 6.7% of the people earn greater than $100,000. So let's go back over here and take a look at our chart that we made and sort of reinterpret what we have here. What our z value tells us is that our value right here is indeed 93% of the normal distribution, 93.8%. So we interpret that to say 93% make less than 100,000, and the opposite, 1 minus that, or 7%, I mean, you know, precisely it would be 1 minus 0.9380, so 6.2, but regardless, so I guess maybe we should make this precise because I know it gets confusing. So we got 93.8% make less than 100,000, and then 6.2% make greater than 100,000. So we had guessed about 8%, and honestly, we weren't far off with our 8%, and had you just guessed, you still would have gotten it right on this test because there weren't any other answers, you know, that were even close to that. So understanding what the question is asking and knowing how to look at that and interpret it using the chart is just, you know, really important in these sorts of problems. So I hope this helps clarify this problem here with the faculty salaries. And of course, you know, you can apply this to any of the problems. However, I'm just thinking to myself, one more thing I could do with this problem to just make, you know, kind of help you is we could take this and multiply it by the number of people to know how many people actually, I mean, I think the question was actually how many faculty members. So in this case, we would take our 6.2 and multiply that times our 200. I'm sorry, it wouldn't be 200. We would take our 6.2 and multiply that by 100, right? Or 6.2 people, roughly, would earn greater than $100,000. So to convert this over, we would take 0.062, multiply that times 100, and we would get roughly 6.2 people earn less than, greater than 100,000. Greater than 100K. So hopefully this helps clarify on this problem, and let me know if something's not clear to you, please.